Using the Chandra's X-ray observatory, astronomers have caught a young sun, a star called SD 61005, blowing a massive, glowing bubble called Astrosphere, a wind-blown bubble filled with the hot gas expanding outwards. I mean, imagine if you could take a time machine back 4.9 billion years ago and watch our sun blowing the same massive bubbles of fire and radiation right into the face of the galaxy. Well, NASA has just found that time machine, and that's where SD 61005 comes in as a game changer, and it's about 120 light years from Earth. In cosmic terms, that's practically the next door. For the first time, Chandra has given us an external ultrasound of an astrosphere around a star that's similar in size and mass to our Sun, but way younger. As you can see in the infrared data from the telescopes like Hubble, there is a massive disk of dust around the star shaped like moth, and that's the mystery. That strong wind should be blasting the dust away. So why does the moth-like structure persist? The fact that wings are still there means the dust is either being constantly replenished by the unseen massive disk, or something very strange is happening that astronomers are still investigating. But it's a clue about how planetary systems evolve. Our sun has also this kind of a sphere called the heliosphere, and it's like the Earth's ultimate cosmic shield, deflecting dangerous galactic cosmic rays that could easily burn our satellites, disrupt the power grids, and even mess with our DNA. And without it, life as we know it, probably it wouldn't exist. The gas is heated up to the millions of degrees, producing X-rays that only something like Chandra can detect. A brilliant X-ray core and a neon purple astrosphere bubble. This bubble is massive. Its diameter is 200 times the distance from Earth to the Sun. But here's the kicker. We live inside our bubble, and we have been studying it for decades with probes like Voyager, but we cannot see it from outside. And it's like trying to describe the shape of your house while stuck in the basement. You get the hints, but not the full view. Now, for the first time, Chandra has given us an external ultrasound of a sun-like star's astrosphere. We are finally watching the outside of the house. It's roughly the same mass and temperature of our sun, but there is a massive age difference. Our sun is a middle-aged 4.6 billion year star, while SD 61005 is just 100 million years old. It's like comparing a 50-year-old to a kindergartner. And since it's so young, SD 61005 has winds of particles growing from its surface that are hundreds of times stronger than our sun, specifically 3 times faster and 25 times denser. And these super winds, these make this astrosphere pop up in the X-rays, and it's the reason why it is called the moth. This discovery gives us a clue about what might have been happening on our sun billion years ago, and it's about our survival also. The heliosphere isn't static, it breathes. So if our sun were currently passing through a dense region of the galaxy like the moth, our protective heliosphere would have shrunk, and it would pull back all the way to the orbit of the Saturn, exposing the inner planets to way more cosmic junk. And this could also affect our satellites and astronauts heading to the moon or Mars. So we need to understand the mood swings of a young sun to predict our own. The moth is just a reminder we aren't just sitting in a quiet void, we are flying through a dynamic, changing galactic neighborhood inside a protective bubble that we are just only beginning to understand.